What is going on? Welcome back to the Lead Automation YouTube channel. Today we're talking about a super hot topic, and that is going to be AI, and how AI is going to impact the manufacturing industry, the automation industry. These are things that we will continue to talk about here on this channel, so definitely hit that subscribe button if these are topics that you're interested in. Now I'm going to start off with just general AI, and one of the biggest use cases that I'm seeing with general AI is the ability to program things more simply. And what will that look like? That may look something along the lines of being able to do like text to code, speech to code, and just using regular human language. So one of the major roadblocks is going to be a developer to develop the libraries necessary to allow this either voice or text to convert to programming language. So really what that boils down to is syntax, right? That every platform, every brand, and every product, let's say for instance like an Allen Bradley PLC versus a Siemens PLC versus a Fanuc robot versus a Yaskawa robot versus, an Epson robot, have their own independent syntax. They have their own independent programming libraries. Now, the thing is like, a lot of the libraries are not very complex, and they're actually like almost all the platforms are like some type of like a C+ or C#, some basis of regular structured text code. Even whenever it comes to like PLCs, PLCs are or can be programmed in structured text, but a lot of times they're programmed in ladder logic. Now, I personally haven't had a lot of experience in trying to do this, but the thing is definitely on the back end that you could have a structured text create laddered logic, because whenever you add a button onto the screen, or when I say you add a button, whenever you add like a contact or a coil, but whenever you add these things inside of your PLC program, there's code in the background that is occurring that is making that plausible and making that item appear on the screen. So if you took it all the way to the very back end inside of Allen Bradley's PLC, and then the way that they generate that ladder logic, there has to be a developer that can develop on that very back end. And then the next challenge is that you have to do that across all platforms. AI would have to become so intelligent to be able to like auto decipher like program syntax. And when I say auto decipher, I mean especially when you're talking about like PLC logic and you're really trying to convert that logic back-end library to be able to do ladder logic. For the AI to be able to analyze that itself, it's going to take a lot of time. I think we're 10 years away from that. Now, given AI is one of those crazy things that it could just be a breakthrough and things could just happen at some point in time where it's like night and day, where AI just becomes like a sentient being and it just knows all things, right? There could be a light switch that's like that and it just occurs instantaneously. As of right now, it's not, AI is not that. A lot of people think that AI is a bunch of tools, a bunch of models, a bunch of, I'll say like programming structures. This is the AI itself, right? They're different programming structures that are tailored towards certain applications. Maybe it's a vision application, or maybe it's the ability to identify images of, like, say for like Google Photos, right? Like identifying a human or identifying a pet or a dog or a cat or that's an example of vision. So that AI is intentionally designed for that, and its back-end coding is done in a way to be able to support that. A lot of the AI stuff that we're seeing right now is it pulling information that's already known information. It's not necessarily teaching itself. Now it could teach itself things that are already put down in textbooks, and even there is a challenge. Is like when you come to the automation sector, like how many of these things are actually in, or how many textbooks are out there on PLC programming, on robot programming. There's not a lot. I'll say there's not a ton of information in this sector, in this industry or whatever, to be able to train an AI tool on, to some degree, right? Like when it gets super intelligent and they can dig through like Reddit and decipher what is trash data versus what's like good data and learn from all those things on its own. Again, this is something that's like over 10 years out. I think it's gonna be a long time before we start to see AI be that intelligent. However, if we wanted to make this AI work in our industry right now on the programming side of things, I definitely see where some certain language models, like I'll say like robot code, it'd be much more simple to feed it that code. And part of the reason why that's so much more simple is because it is a structured text language, whereas like PLC programming is not a structured text language. So therefore you have to convert ladder to structured text, and you'd have to be able to train that in, and you'd have to have somebody who is capable of training that in and who has the expertise to be able to train that in. And there's not honestly too many people in the world that have those type of capabilities. But when it comes to like robot's more simple, again, because it is a structured text language and it's really a more simplified language. Now there has been some people who have been able to do regular structured text languages with AI and generate code that was usable, workable code. But yeah, this is where I really think we're at with AI and being able to utilize it in the automation industry. It's gonna be a lot more challenging again with PLC. If we can do the same thing with PLC where we can just convert structured text, ladder logic very easily, then I don't think we have any problem at all. Again, I think that's just going to be a challenge for some time. And you could also still program, PLCs in structured text. But the thing is, industry just generally doesn't want to program PLCs in structured text. So therefore, it's probably not going to really accept, right? Like a lot of customers that if you were to try to give them, or manufacturers, if you were trying to give them a structured text programmed system, they would, essentially reject the system. Said, no, we can't accept a system that's written in structured text because, a lot of technicians don't know how to program in structured text. So that would be the challenge. And also, I don't really understand on an executional standpoint, like how Alan Bradley doesn't have like the ability, and all the PLCs that have the ability to do structured text and ladder logic, I don't understand how there's not basically a view option, meaning view in structured text, view in ladder logic, and it automatically just converts the code to do the exact same thing in whatever language you want to see it in, right? Maybe it's function block diagramming, and so you can, basically just click view, and they have like their software has the ability to adapt the code on the back end to be able to view it in the way you want to view it. So if they do something like that, then that will definitely open up the door. And this is where I say that developers really, really needed when it comes to developing these type of systems. Because if you simply had the ability to just convert regular structured text to ladder logic, boom, no problem, done. I think that the AI is going to be very, very close to being able to execute that code or be able to write that code. But then the next challenge is when it comes to automation and manufacturing, there's a lot of moving parts. So I think the next thing that's really going to have to happen is people are going to have to really step up in simulation softwares. They're going to have to utilize simulation softwares and just invest in them. They're expensive softwares. A lot of people also don't want to they don't want to invest the money in the software. They can be tens of thousands of dollars a year, and they also don't want to invest the resources to create digital versions of their systems, because there's a lot of work that goes into making a system completely functional inside of a autonomous environment or a simulated environment, especially when you're talking about like very complex, like material handling, custom, special purpose machine type of equipment. If you, like stuff like robotics, like that's fairly easy because like a FANUC robot's a FANUC robot, and there's already simulation software's there. It's the same model number robot, or not that it's the same model number robot, but it's not all custom is what I'm getting at. Versus like if it's custom, then you have to rebuild every single nut and bolt of the machine every single time inside the simulation software. So like there's the mechanical engineering, and there's another level of basically doing engineering to create motions and animations on each individual joint that you want to move and constrain other joints that you don't want to move from moving. So again, there's a lot of work that goes into that, but I think that we're going to have to we'll see a lot more people using it when AI makes programming easier, because now we need to test AI programs. So, these PLC programs and robot programs, we just wrote it with the AI. It's going to have to be thoroughly tested before you even try to run that in a machine, or we won't be able to run any code that is going to actuate any outputs. Or we have to go through one by one and simulate that code. So as like a PLC programmer, you have ways of being able to simulate how a system will operate, and you'd have to go through and individually test every single functionality of the system very thoroughly, and then like one by one test each output of the system, and you just have to do this process very, very thoroughly and have like very good systems in place to make sure that like when you power the system on and you hit cycle start, that like the system just doesn't eat itself alive things inside of things. Like, these things happen anyway in the real world when it comes to automation. But whenever you have like all your code just auto written for you by AI, it becomes really easy just to download that program, hit cycle start, and and then see some devastating tragedy happen with the equipment or even human safety. So hopefully this was useful. If there's more things you'd like for me to elaborate on, let me know. I went quite a bit deeper on this particular topic and like a lot of the nuts and bolts of everything more than I wanted to. I just wanted to do more of a high level overview, but I went deep with it. So if you would, just let me know in the comments below if there's anything else in particular that you would like to see, and we'll catch you in the next one.